Right. Hello, and this is sort of a new chapter, if you like, of maths. Now, these look quite complicated equations, if I'm honest, on the board. So basically, integral of 3 to 1 of x to the power of 4 plus 4 over 2 is dx. And then we've got here the integral of 4 to 1 of 2x, take 3 root x plus 1 is dx. A lot of x's in there. Basically, this is an equation of, it could be anything. It's mainly, well, I'm going to say anything, I don't mean anything, it's an equation of a graph, but it could look like anything. I don't know what those graphs look like. I'm just simply working out the integral of these graphs. And we'll go into a bit more in a minute what we mean by the 4 and the 1. But obviously, we see an integral sign here. Now we should know from C1, what we need to do now is integrate them equations. I think what I'd do, if I got this in an exam, I'd sort of, before I integrated it, to stop myself making any stupid mistakes, I'd sort of simplify it. So, I'm not talking about the sense of taking 2 out of everything. What I'm talking about is where there's a root sign, that's x to the half, for example. So, we'll do this equation first, it looks easier to do. So, keep the integral sign for 1, 2x, you don't need to change that. 3 root x is the same as 3 to the half, plus 1. And this will become easier when we do decide to integrate it. 3 to the 1. And now for this one, we split the equation as x to the 4 over x squared plus 4 over x squared. Now we could rewrite that as plus 4x to the minus 2. I'm actually going to do that. Yeah, I'll do that. Stop me getting confused, because otherwise I could get quite confused. Plus 4x to the minus 2. So they're exactly the same as these two. So that's exactly the same as that, and that is exactly the same as that. All I've done is wrote it in a slightly different format. But again, they mean exactly the same thing. So let's actually integrate these. Oh, actually, yeah. This isn't as simplified as it could be. Sorry, x to the 4 over x squared is actually you've got x to the 4 over x squared. 4 take 2. I should know from our indices work in C1 that is x squared. So that actually simplifies to x squared plus 4x to the minus 2. So we integrate these equations. What you do, so we'll actually integrate these now. Actually, give me something more than that. Do this one first, it looks a bit more challenging. 3 to the 1. X squared, because what you do is you raise the power by 1 and divide by the power, so that becomes x to the 3 over 3. There's secretly a 1 there, but they don't show it. Raise the power, minus 1, divide it by that power, so plus 4, x to the minus 2, minus 1, and we divide that by minus 1. So obviously that's going to turn out to be a negative. So when we finish integrating this, 3 to the 1, we get a third of x cubed plus take 4x to the minus 1. So that's your integrated equation for this one. And we'll do the same for this. We integrate this equation. So what we do the same sort of things we did in C1. So we've not done anything new here at all. So raise the power of 2x. So that's 2x squared over 2. Take 3, raise the power. So that's 3 over 2. So 3x to the 1.5, or 3 over 2 is better putting it, over 3 over 2. Plus 1x over 1. Now we can simplify. I've given myself a bit more space on the right because we're divided by a fraction here. Now we could just put that in our calculator and work it out, but a bit more stake. You might get a few more marks for doing it this stage. So I'm not going to simplify anything yet. So we've still got 2x squared over 2. And now instead of writing this here, I'm going to times the whole equation by 2. What I'm going to essentially do is bring this 2 to the top. Sorry, 2 to the top here. So 3 times 2 is 6. So this is going to become 6. So it's minus 6x about 3 over 2 over 3. Now that would give us exactly the same answer as that, but it's just nice to get into the habit, because in C1 you don't have a calculator, so it'd be quite hard to divide like 9 by 2/5. Well, it wouldn't be hard, but you know, you get the idea. You can't do it in your head like that unless you're a genius, which obviously I'm not. Plus 1x over 1. See, all I've done is change the middle term here and made it look a bit simpler. So if we now simplify this, we get x squared, and you can always double check these. Sorry, x squared plus take 2x 3 over 2 plus x. Now if you wanted, so this is our end equation here. Now if we wanted to check these two equations, what we do is we'd go back and have a go at differentiating them to get our original equation. Just integrating one way, differentiating is going the other way. You can think of it like that. You can back to 0, so to speak, and that will get you your two sort of curves. So when we differentiate that, we should get that. When we differentiate that, we should get that. So all we've done is used C1 skills here. Time to bring a bit of C2 to the party. So what I'm going to do is I'm going to rub all this working off. I'm going to... well, actually, I'll leave this on here. I'll just draw it in a different colour. Because I'm going to need... I've not got enough space here. I'm going to need to rub some of my working off there for the left-hand one. But for the right-hand one at the moment, I'm just going to continue like I don't care. Which obviously I do. So, now C2 is concerned with these two bits here. Now in C1 all you had was a basic integral sign. It says integrate that, which you know is fairly simple. So what this means is find the integral of 4 and take it away from the integral of 1. So the top number on the top of this integral here always has to be bigger than the bottom integral. The bottom number on the integral. Otherwise we'll be taking a negative away from a positive, and we'll just get negative, which as you find in what you're doing here, essentially, is finding the area of the curve, and you can't have a negative area. So, I'll go into more detail in that in a minute. So that's why you can't have a negative. But if you don't worry, if you don't understand what I've just said there, don't worry, there will be time to, I'll go over that later. So, what we do is simply find the integral of this, substitute 4, find the integral again of this, which we would have already done for finding out 4, and substitute 1 into the integrated version of this, and take the integrated version of 4 away from the integrated version of 1. Now, again, that sounds complicated. I'm going to go into it, don't worry. So, this is our integrated equation here. So, basically what we do is sub in 1. So, we've got 1 squared. Take 2 times 1 to the 3 over 2 plus 1. And that gives us our integrated equation for 1. Make sure I'm doing this right, actually, sorry. Yeah, that's right. I'll make sure I've integrated it. Yeah, sorry, I'm just making sure I integrated it right. Now, actually, I've kind of done it wrong there. Sorry, I've just seen this part. So, this integrated equation here, when we're integrating it, when we're putting our value in, what we do is we put like 4 at 1 there. Is that right? Yeah. And then we substitute in our values. I just missed out that bit there, and then you substitute it in. Otherwise, people don't know that's an integrated equation, because otherwise you're losing the integral, and you don't want that. So this comes. I even wrote it. 1 squared 1. 2 times 1 is 1. So, and that is going to be, so 1 squared is 1, 2 times 1 is 1, so 1 take 2, minus 1 plus 1 gets you 0. Sub in our other equation, so we've got 4 at the top, 4 squared, take 2 times 4 to the 3 over 2, plus 4 equals 4. Now I've not just done it off the top of my head, I have done it in a calculator previously, but all I'm doing is just go over it. So that's how you work out that equation. So you do 4 minus this answer. So when you sub in 4, you take that away. When you sub in 1, and that gets you. It's quite confusing, that one, because it is just 4, but that's not just that answer. It's that one minus that one, and that equals that. So that is your end equation. And if you find out the area between a curve, so this is the area between the 2 points, the horizontal line and the curve. So I'll just draw it out so you can imagine it. Oh my god, I have to do this quick because my car is going to die. Yeah, so we've got a Y thing here. Oh, actually, I'll plug in my calculator. So you have to give me a minute so you don't miss this. Sorry about that. So I was just assuming that we've got a Y and X thing there. So I'll continue. This is basically, sort of what every single integration question is about. It's about finding the area under a curve. Now, if you can't see this, I'm sorry, but we'll go do it again. Don't worry. So I don't know why we just do it later. Actually, yeah, we'll do it later. Actually, do we? Yeah. So they're the integrals, and you do the same for this one. You'd sub in 3 and you'd sub in 1. I'm not going to work it out. I don't have enough space at the bottom for the left hand side one, so I'll let you do it yourself, but I'll just write the answers up, so if you don't want to hear them, pause the video so you can get the question down. So it's that one on the left. I've done the one on the right for you, so if you want to pause the video and you know, have a go at it, you can. Right, welcome back. So if you have had a go, for the left hand side one, you should have got. No, I'm just trying to find the one where I did it. Oh, no. Right, I don't know actually. It's quite bad. Never mind. Sorry about that. Yeah, so you should have got something I didn't get. Never mind. I'll do it later. Don't worry. Right, so hopefully you've got them two down. I don't know why I wasted my time and your time doing that. I can't leave any of these down, by the way. I've got, I need the space. I'll write them back up at the end, and I'll take a photo of it or whatever. I don't. Sad, never mind. Right, okay, there's our board back. So, I'll do a sort of simple one killer. No, I'm just choosing a question, an exam question to do to get you used to the facts. Yeah. So. Sorry, I'm just trying to choose a question to do. That is kind of challenging, but again, it's doable. Come on. Right, okay, I'll have a stab at this one then. If I get it wrong, I'm terribly sorry, but never mind. So, I tried to pick a hard one. So we've got this graph here. I'm just drawing it out for you. Kind of goes down there, and then we've got sort of a line here, horizontal line. That isn't part of the graph. The graph comes down through the origin here, and sort of goes up, and comes back down. Right. And it goes back up. So this line here, horizontal. So basically, this is the graph, yeah. And this dotted line here is basically a line connecting these 2 points. sorry. So what we've essentially got here is we've got n and we've got p. And it's asking us to find the value of r, which is this section here. We'll just sort of colour in. Shouldn't do it in the same colour, shouldn't I? So, sort of like that R section. It says, work out the area of that. Now, I'm no genius, clearly, but I'm going to say we can't use cosine, sine, or half, you know, the standard rule for finding area of a triangle. Firstly, because that isn't really a triangle. Well, it is, but it sort of curves, so we couldn't work the area using simple methods, and obviously you wouldn't be expected to do that at AS level. So it says find the area of R. It gives us the equation, thankfully, of this graph, and it says y equals, x cubed. I'm going to need my calculator, I know it. X cubed, take 10x squared. Is that the equation? Yeah, I think it is. Y cubed, take 10x squared plus kx. That's it. Now it says k is an integer, so that's the equation. So the equation, if you can't quite see it, because my head's in the way, is y equals x cubed plus, take 10x squared plus kx. So, right, I know it seems to like just disappeared from your screen for a second there, but don't worry, it's not your like loss of concentration, I hope. But basically what I did was made a massive mess up of that. I explained to you what I did wrong, and it might help you because you might have done the same thing. So, as you can see, we've got, I'll get out of the way for you there. So we've got an equation of the curve at the top, and it's told us, just a bit of vital information, that P there, where it says 2, yeah, that is a maximum of the curve. Now, I overlooked that before and simply tried to find out the value of, because what it was asking us to do was show that k is 28, and I was trying to figure out, or putting 2 into the equation to get a y, which we didn't have. You know, which would be all nice if we had y, but obviously I was left there hanging for about 5 minutes trying to figure out what I'd done wrong. But I spotted it as soon as I reread the question. So you need to reread the question. If you're not seeing it, you're missing something, because all the information will be there. For some reason I didn't believe it until a minute ago. So it told us that P is a maximum. So if you've watched our differentiation video, you'll know that the second derivative, when it's a maximum, the second derivative is going to be negative. So that allows us to find out, obviously, y. So we're going to do the first derivative of c. So that'll be 3x squared. So I just put dy dx equals 3x squared, as this is just simple differentiation, to make 20x plus k. If we differentiate that again, we get, oh wait, no, actually, sorry, we could, no, we could do that, yeah. You don't need to do the second differentiation bit, sorry, differentiate. So we know dy dx is 0 at maximum, because you can basically draw it, it's like the horizontal line, it's even showing you there. So 0 equals dy dx, which is 0 equals 3x squared, take 20x plus k. Now the reason I didn't differentiate twice there was because I'm trying to find what k is. And if I differentiated again, I would get rid of k, and I want to know what k is. I know the second derivative is going to be negative, I know that. It tells it me in the question. It's not asking for me to prove that. What it's asking for is to find k. Now, we know that this equals 0, and we're at our point 2. So when x is 2, dy dx is 0. So let's find that. So 0 equals 3x squared. So if we put our, I'll get out of the way a little bit. So put our equation in, 3 equals, so 3x squared, we've got our x value of 2 squared, take 20x, which is 20 times 2, plus k. Sorry, I'm trying to do it on this slide here. So 3 equals 2 squared, I'm doing it on the side by the way, so It's going to all good. 2 squared is 4. 3 times 4 is 12. Yeah, take 20. 20 times 2 is 40. Plus k. Yeah, this is definitely the right way to do it. And that gets us 0 equals 12. Take 40. If you work that out in your head, you should get minus 28. And obviously k is going to equal 28 plus k is 0, so k is equal to whatever that minus number is, which is 28, so k is equal to 28. Now you could say k is equal to 28, there's no other way of trying to cut corners there. So that shows you k is 28. So that's the first bit done and dusted there. We've proved it. Now for this you'd know you don't get a mark for the answer because it says show k is 28. What it wants you to do in this question is, exactly, show it's 28. Did you work out that it is 28? You need to show. So that means you can't skip any corners in terms of working it out. Otherwise, what you do is throw marks away for an answer that you get right. And all it would take is a few minutes for you to write it down in the exam, which is understandable if you can't be bothered. Then I ask, well, why are you doing maths? Never mind. It kind of says why you're watching the video, to be honest, because I'm a plump. Never mind. So, we worked out k. Now, we can get rid of this rubbish here. So, you don't need to get rid of this, but if you do an exam question, keep it, but I'm not going to because I'm not, just to free up a bit of extra space. You don't go, oh well, I did it, crossed it out. I mean, I did it, it's a brilliant tip, X, I did it. You should have been there when I crossed it out examiner. No, it works, unfortunately. As much as you'd like it. So, we can put k, we know k is equal to 28. So, that's our first derivative there. We can leave it on in case we need it in the second equation. So that was part A, done. Then it says, the line through P, which is parallel to the x-axis, cuts the y-axis at point N. The region R there is bounded by the y-axis Pn, as shaded in figure 2. Use calculus to find the exact area of R. Now, it's not asking, what it's asking for, we need to use integration. This is the bit that requires our knowledge. So, I'll just read that again. So it says the line through R, through P, this, parallel to the x-axis, cuts the y-axis at point N. So what it says parallel means it has the same gradient. You know that from C1, and it's a straight line, so we know it's the same gradient as the x-axis, which is what it tells us. And it says it cuts the y-axis, so I should label that at point N. So I just put yx, sorry. Should put that before. And it says the region bounded by C. Our region is bounded by C, the y-axis, and Pn, shown in figure 2. Work out the area of R. Okay, so what we need to do is obviously find the red R bit. Not really mathematical, but never mind. So a good way of starting this actually. Sorry, just need to double check my answers before I explain it. Right, sorry about that again. I totally, utterly just was stupid. Never mind. Okay, so we've got a coordinate of 2 here. We know k is 28. So to get the y value for p, which is the first thing we need to do, so we can find the y value of n, because of the same height. Y value is the height, essentially. So put this into equation. So y equals 2 cubed, take 2 squared, which is 4, times 10, which is 40. So take 40, plus 28 times 2, which is 56. Simplified out, y is 24. So we know the height is 24. So n, if it's 0, because it's 0 point along the x-axis, it's a height of 24. So it's coordinates 0, 24, 2, 24, 0, 0, and we've got here is 2, 0. So we've got sort of coordinates for a rectangle there, essentially. How are we going to incorporate that to find R? Well, what we need to do is find... Oh, I'm doing a different colour, actually. Crazy times. Oh, God. What we need to do is we need to find... We'll call this C. Oh, actually, no, that's confusing. Call it A. So this part here is A. And that's the area under P. So A is the area under P. And now A plus R, sorry, it doesn't specify this in the mark scheme if you're looking at it, equals 2 times 24. As the area of this rectangle is the same as A, the area of A plus the area of R. Now the area of A is the integral of P. If we put x from P into the integrated equation, which we need to create, that will get us the area under P. So, as I said, the first thing we need to do is integrate the equation. So, we integrate that equation up here for C. We'll just put this equation, so raise the power by 1 and divide it by the power, x to the 4 over 4, take, raise the power, so 10, x to the power 3 over 3. And we know k is 28, so we put 28x, and raise the power of 28 of x, which is 2, divided by 2, so that gets us plus 14x squared. Now you can see how I got that as the integrated equation there. So if we put x into that, what we essentially get is this area of A. So we put x, we know is 2, so the integrated equation, sorry my terrible writing, so we know 2 to the power 4 over 4, take 10, 2 to the power 3 over 3, plus 14 squared, so 14 times 2 squared, which is... No, that's really bad. Sorry, I'm just have to redraw this. Was it 14 2 squared? So it's going to be 14 times 4, so the integral equation comes... I don't know, I really can't draw integrals, I don't know why, just, I can do the maths, just can't draw the integrals. The integral of that equation, sorry, without doing that, so that comes to 4, that's 80. So I'll just put it 4, take 80 over 3, 14 times... Yeah, I could do it with my calculator actually. I'm pretty sure that comes to 100 over 3, but I'll have to be certain. 14 times 4, 56, plus 56. So the whole integral comes to 4 take 80 over 3 plus 56. Yeah, I was right, 100 over 3. So the integral is 100 over 3. Sorry, my error doing that. So basically, what the integral tells us is that this area A, so that's essentially equals A. So the area of A is 100 over 3 centimetres squared, if it's in centimetres, or whatever area you're measuring in. That's quite clever actually, if you think about it, because we've not had to measure the diameter of this or anything. All we've done is just simply, well, that's a coordinate there, we've worked it out. Simple. You know, simple enough. So we know that 2 times the area, we need to find, what, it's very good, we found the area of A, brilliant. It's not asked us to do that, but we found it. We want the area of R. Now, the whole area is 2 times 24, because the height is, the width is 2, the height is 24. So, if I can get pen lid off, that's 2, it's 24. Shouldn't really do it in blue actually, because that's kind of confusing, right? So 2 times 24 is 48. So 48 equals, what was it? How did I do it? So I'm just making sure I know how I did it. 48. Take 100 over 3. Yeah. So, I'll write that wrong around actually. R is equal to 48, which is 2 times 24. Take 100 over 3, and that gives you R. And R is equal to 14.6 recurring. Or if you wanted it to be a bit more accurate, it'd be 14 14 plus 2/3 is what it should show in your calculator, and that's 7 meters squared or whatever you're measuring it in, and that gets you the value of R. Well, that was a long tutorial. Anyway, so that's the end of it. So that is essentially what it is. It's simply, but yeah. So it's just a very quick overview, and we'll see you in the next video.